Here are some exponential and logarithmic forms. Now the objective of this lesson is to convert exponentials into logarithmic forms. Now let's solve for the exponent of base to the exponent equal to power. Exponent, by law and definition, is equal to the logarithmic form of an arbitrary base. Inside is the power in the bracket. Exponential is equal to log base power. Now in problem 2, the first way normally we would assume is 3 to the x is equal to 3 to the third. That is technically correct, but we want to find the logarithmic form of this. So using the definition of logarithmic rules to convert to a log form, you have x is equal to log base 3 of absolute value of 27. Simplifying it further gives you 3 to the 3. They are inverses of each other, the logs and the exponentials, so they cancel each other out, which gives you x equal to 3. And that's the canceled out definition. More of these rules and log properties will continue in the future lessons. In example 3, 5 to the x is equal to 7. Now, mastering our powers of numerical exponentials will not work here. So, by definition, we need to use the logarithmic rules. Base is 5. The exponential is denoted as the parameter x. 7 is our power. And that's what we left with x. Can't break it down any further, by the way. Now, in part 4, problem 4, example 4, assume a to be a constant, an arbitrary one. We want to solve for d. A to the d is equal to 25. Rewriting it into the logarithmic form will give us d as the exponent equal to log a 25, the power is. Let's solve for z in this last example. Now, the same thing as I said about example 2, we would normally assume, since these two have the similar laws of exponent power rules, we would obviously assume by solving using algebra that z is equal to 5. But we prefer, for this video, using logarithmic rules. So the exponent here is 2z minus 7. The base is 10. Generally, by the way, 10 is a common base when you're doing logarithmics, other than base e. And 1000 is 10 to the third. So 2z minus 7 is equal to log base 10 of 10 to the third. That cancels out, according to the fact that exponentials and logs are inverses of each other if they have like bases. Now 2z minus 7 is equal to 3. If you solve for z, you get 5. Now, for all these answers you see here, you can verify by plugging them back into the original problem. And if both sides are equal, then you got the right answers. Up next is logarithmic to exponential forms. Now stay tuned.